Hi, I am Dr. J. Suresh Goud, Associate Professor of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss test of hypothesis for small samples. The subtopic is chi-square test 1. As of now, in the previous sessions, we discussed test of hypothesis for small samples, 3 topics. First one, t-test for single mean. Second one, t-test for difference of means. And third one, f-test. According to the description of the problem, we have to identify which test is suitable for the given problem. In case, if the problem consists of only one small sample, we use t-test for single mean. In case, if the problem consists of 2 small samples, we can use either t-test or f-test. To test whether there is any significant difference between means of the sample, we use t-test for difference of means. Suppose if we are going to test whether there is any difference between the variances of the samples, we use f-test. Like that, we should remember which test is suitable for the given problem. Now coming to fourth test, which is chi-square test 1. Here, we do not have any samples. We have only the frequencies. The problem consists of observed frequencies data. Based on observed frequencies data, we should find expected frequencies. According to the problem, we have the data only observed frequencies. We should find the expected frequencies based on the observed frequencies. See, to test whether there is any significant difference between observed frequencies and expected frequencies, we use chi-square test. Observed frequencies, the symbol is OI. Observed frequencies O1, O2, O3, O4 like that. Expected frequencies EI, E1, E2, E3 like that. This data we are going to take from the problem. This data we have to find out from the observed frequencies. If we know these two values, observed and expected frequencies, we use the formula chi-square equal to not x square. Don't be confused, which is chi-square, the mathematical terminology. Chi-square equal to sum of or sigma of OI minus EI, observed frequencies minus expected frequencies whole square by expected frequency. In step 4, test statistics. And in step 3, this chi-square value we can choose at n-1 degrees of freedom from chi-square distribution table. In step 3, level of significance. In step 4, this formula. Now, how to get these expected frequencies? How to get these expected frequencies? We have in this chi-square distribution, 3 methods are there to find expected frequencies. To find expected frequencies, we have 3 methods. Method 1, method 2 and method 3. Suppose if I go to method 1, finding expected frequency in one way. In method 2, finding expected frequency in another way. In method 3 also, we can find out expected frequency in another way. 3 different methods to find expected frequency. But all the 3 methods, the formula, the test statistic chi-square is same, which is sigma OI minus EI whole square by N. But finding expected frequency in different methods in a different procedure. First, we are going to discuss method 1. In method 1, the problem is the number of automobile accidents per week in a certain area as follows. The number of automobile accidents per week in a certain area as follows. That means in a particular area, per every week, for suppose first week 12 accidents, second week 8 accidents, third week 20 accidents, like that 10th week 4 accidents. Total 10 observations are there, n equal to 10. N equal to 10. 10 weeks, first week 12 accidents, like that, last week 4 accidents. Are these frequencies, are this data, frequency means chi-square distribution, in agreement with the belief that accidents were same during last 10 weeks? During that we have to find out by using method 1, because in method 1 we have given only the observed frequencies 12, 8, 20, 2. OI values are given 10 values. We should find out EI values, expected frequencies. In method 1, how to find this expected frequency? Which is very simple. Expected frequency means just average of all observed frequencies. We can find out expected frequency in method 1 by using the average of all observed frequencies. So, EI means average of all observed frequencies. 10 observed frequencies are there. The average is 12 plus 8 plus 20 plus 2 and so on, 4 by 10. So, we got it. Expected frequency is 10. Expected frequency is 10. So, we got 10 observed frequencies, 12, 8, 20 like that. But we got only one expected frequency. For each observed frequency, we can write the 10 observed expected frequency. We can take expected frequency 10 for all the 10 observations. Like that, we should find out expected frequency from the observed frequencies only in method 1, which is the average of all observed frequencies. After getting expected frequencies, this OI, observed frequencies, are given 12, 8, 20, 2, 14, 10, 15, 6, 9, 4. This we have taken from the problem. And expected frequency we calculated, average of observed frequencies, which is 10. So for corresponding observed frequencies, we have written 10 in all cases, on 10 cases. After getting OI minus EI, actually the formula is OI minus EI whole square by EI, sum of. So to calculate this value, first we have to find out OI minus EI whole square. OI minus EI whole square. OI is 12 minus 10. 12 minus 10, 2. 2 square, 4. Now coming to second one, OI is 8. EI is 10. 8 minus 10 minus 2 whole square, which is also 4. 20 minus 10, 10. 10 square, 100, because we are doing the square. 2 minus 10, 8. Minus 8 whole square, 64. 14 minus 10, which is 4. 4 square, 16. 10 minus 10, 0 whole square, 0. 15 minus 10, 5 square, 25. 6 minus 10, minus 4 whole square, 16. 9 minus 10, minus 1 whole square, plus 1. 4 minus 10, minus 6 whole square, 36. So the numerator value we got it, OI minus EI whole square. But in chi-square formula, we have OI minus EI whole square by EI we require. By EI we require. This is OI minus EI whole square. By EI values are also there. We can do OI minus EI whole square by EI. OI minus EI whole square how much? 4. By 10. 4 by 10, 0.4. Now coming to second one, 4 by 10, 0.4. 100 by 10, 10 only. 64 by 10, 6.4. 16 minus 10, 3.6. 0 minus 10 by EI, 0. 25 minus 25 divided by 10, 2.5. 16 divided by 10, 1.6. Similarly, 1 divided by 10, 0.1. 36 by 10, 3.6. So we got it, this values OI minus EI whole square by all values. If we do sum, sigma, that means 0.4 plus 0.4 plus 10 plus 6.4 plus 1.6 plus 0 plus 2.5 plus 1.6 plus 0.1 plus 3.6. If you add all the terms, you got it 26.6. This is chi-square value in step 4 in the procedure. Step 4 in the procedure of test of hypothesis. What are the remaining steps? Step 1, step 2, step 3 and step 5 common like previous tests. Now, what is step 1 in the procedure of test of hypothesis? Null hypothesis. We are going to set up null hypothesis. We have to assume that there is no significant difference between observed and expected frequencies. We are going to assume that there is no significant difference between observed and expected frequencies. This is our assumption. Alternative hypothesis H1 means there is a difference between observed and expected frequencies. Both two are our assumptions only. Our assumptions only. Now, level of significance alpha value not given. Generally, the standard level of significance we are going to take 0.05. Now, we have to choose chi-square alpha value at n-1 degrees of freedom from chi-square distribution table. Chi-square distribution table. Chi-square alpha value generally we can take 0.05 at 9 degrees of freedom because n equal to 10. The total number of observed frequencies are 10. That's why chi-square 0.05 at 9 degrees of freedom value we have to see from chi-square distribution table. I'll show you how you get that chi-square 0.05 value from the distribution table. This is chi-square alpha, critical values of the chi-square distribution. Alpha values are given 0.3, 0.25, 0.2. Our alpha value is 0.05. This is how many degrees of freedom? 9 degrees of freedom. This is 9 degrees of freedom, where degrees of freedom equal to number of independent variables, which is n minus 1. Actually, the number of observed frequencies are 10 minus 1, 9. The corresponding value is 16.919. So, chi-square 0.05 at 9 degrees of freedom is 16.919. This value we are going to choose as a tabulated value in step 3. So, therefore, chi-square 0.05 at 9 degrees of freedom equal to 16.9 value. This is the tabulated value. Now, step 4, test statistic formula. Already we have discussed sigma OI minus EI whole square by EI. This value we have calculated by using the table in the previous slides. So, which value is 26.6. After getting chi-square, the mod chi-square is 26.6. And chi-square alpha, we got it 16.9 from chi-square distribution table. Now, in the conclusion part, compare these two values. So 26.6 value, which is greater than chi-square alpha. That's why we used this relation. Chi-square, mod chi-square is greater than chi-square alpha. According to the procedure of test of hypothesis, if it is greater than, we are going to reject null hypothesis. Means, actually what is null hypothesis? H0 is OI equal to EI. This is we are rejecting. That means there is a difference between observed and expected frequencies. Both are not same. We concluded that observed and expected frequencies are not same. Now going to second problem on chi-square distribution. The statement of the problem is the following figure shows that the distribution of digits in numbers chosen at random from a telephone directory. Test whether the digits may be taken to occur equally frequently. Frequency word is given. That's why we are going to use chi-square test to solve this problem. On telephone directory, we have digits 0, 1, 2, 3, up to 9 is there. The frequency, how many calls we got it for 0, for 1, for 2, for 3, like that. That means these are the observed frequencies are given. How many observed frequencies are there? 0 to 9. So totally n equal to 10. In chi-square distribution, actually what is the formula? Sigma oi minus ei whole square by ei. This is the formula. But in this formula, as of now, we don't know expected frequency. And I told you that how to find expected frequency in method 1, average of all observed frequencies. We know all the observed frequencies. We have to find out average of all the observed frequencies. 1026 plus 1107 plus 997 and so on. 853 by 10 average. So we got it expected frequency 1004. And we know all the observed frequencies and we know unique expected frequency for all the observed frequencies. Now we are going for table. Observed frequencies are given 1026, 1107 up to 853. 10 values are given. And we calculated expected frequency. How much we got it in the previous slide? 1004. That we have written corresponding to all the observed frequencies. Now, according to the formula, this value we require. So, first we have to do OI minus EI whole square. We have OI values and EI values. OI minus EI, 1026 minus 1004, which is 22. 22 whole square is 484. Similarly, 1107 minus 1004, how much? 103 whole square, 1069. Similarly, 49, 966 minus 1004 whole square, 1494, 1075 minus 1004 whole square, 5941, 973 minus 1004 whole square, 961, 1107 minus 1004, 10,609, 972 minus 1004 whole square, 1024. Like that we can find out OI minus EI whole square. By EI, this is OI minus EI whole square by EI. 484 by 1004, 48.4, 1069 by 1004, 1060.9, 49 by 1004, 4.9, like that we can calculate all the values of OI minus EI whole square by EI. This sum if you do will get sigma. So finally we got it chi-square equal to 5462.2 test statistic value. Now the procedure of test of hypothesis for chi-square distribution, we have 5 steps. First one, null hypothesis, H0. We have to assume that OI equal to EI. That means there is no difference between observed and expected frequencies. Similarly, we are going to assume that there is a difference between observed and expected frequencies. OI not equal to EI. And level of significance alpha not given, we have to take the standard level of significance at 0.05. And chi-square alpha for n-1 degrees of freedom. So chi-square 0.05 at 9 degrees of freedom. This value already we have taken in the previous problem. The same value we are going to take it because same 9 degrees of freedom. 16.919. And in step 4, we calculated chi-square equal to sigma OI minus EI whole square by EI. This value we have already calculated, 5462.2. But we should take mod x mod chi-square because if there is any negative value, we have to take positive value. And chi-square alpha in step 3, we got it 16.9. 16.9. And in step 4, mod chi-square 5462.2. And in step 5 conclusion, we have to compare these two values. Mod chi-square value greater than chi-square alpha. That statement we have written here. According to the procedure of test of hypothesis, if we get greater than value, we are going to reject the null hypothesis. Actually, what is null hypothesis? OI equal to EI. That means there is no difference between the observed and expected frequencies. But we have to reject this statement. We have to reject this statement. Means there is a difference. Like this. There is a difference between observed and expected frequencies. This is the conclusion of the problem. Similarly, we can do the exercise problems also. Suppose if I take the first example, same that 200 digits were chosen at random from set of tables. The frequency of the digits are given from 0 to 9, means n equal to 10. All observed frequencies are given. Use in the question itself, we mentioned that use chi-square test. Directly we can use chi-square test to assess the correctness of the hypothesis that the digits are distributed in equal number in the table. You can use the chi-square test method 1. How to find expected frequency in method 1? Average of observed frequencies. And coming to the second problem, a die is thrown 120 times. Frequency is 120 times and the frequency of various phases are n equal to 6 only. Either it may be 1, 2, 3, 4, 5, 6. On die, we have 3 phases. So, to get number 1, 10 times our chances are there, 15 times our chances are there, 25 chances are there, 25 chances are there. To get the phase 5, 18 chances are there. To get phase number 6, 27 chances are there. So, total if you add 120 times. And these are the observed frequencies O1, O2, O3, O4 and so on, O6. We can find out expected frequency by using the average of observed frequencies by using method 1. After getting the expected frequency, the remaining procedure is same like previous problems are discussed. Okay, thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.